So good day everyone. In this video we will help you to understand Riemann sums, a method used to approximate the area under a curve, and this concept is very important in calculus because it leads the idea of the definite integral. So, what is Riemann sums? So a Riemann sums works by dividing a region under a curve into several rectangles and then adding up their areas. The more rectangle we use, the closer our approximation becomes to the true area. So, we use Riemann sums because many curves do not have simple geometric formulas for area. Instead of solving the entire curve at once, we break it into smaller, manageable pieces.
Let's begin with the left Riemann sum. In this method, we use the left endpoint of each subinterval to determine the height of rectangle. For example, consider the function f of x is equal to x squared on the interval from 0 to 4, divided into 4 equal subintervals. This gives us a width of delta x is equal to 1. Using the left endpoints 0, 1, 2, and 3, we calculate the rectangle areas and add them together. The total area using the left Riemann sum is 14. For an increasing function like x squared, the left Riemann sum underestimates the true area because the rectangles fall below the curve.
Next is the right Riemann sum. This method uses the right endpoint of each subinterval as the right rectangle height. Using the same function and interval, the right endpoints are 1, 2, 3, and 4. When we calculate the areas using those values, the total comes out to 30. For increasing functions, the right Riemann sum overestimates the area because the rectangle extends above the curve. To improve accuracy, we use the midpoint Riemann sum here. We take the midpoint of each subinterval and use its function value as the rectangle height. This method gives an approximation of 21, which is very close to the true value of 21.33 point. This shows that the midpoint method is unusually more accurate than left or right sum.
So here we had trapezoidal rule and applications and conclusion. And another improvement, it's the trapezoidal rule instead of the rectangles. This method uses trapezoids by averaging the left and right endpoint heights. For example, the trapezoidal rule gives an approximation of 22, which is closer to the true area than either the left or right sum alone. As we increase the number of subintervals, all these methods become more accurate and eventually approach the exact value. This idea is the foundation of the fundamental theorem of calculus. Riemann sums have many real-world applications. They are used in physics to compute displacement, in economics to estimate cost and revenue, and in science and medicine to analyze data over time.
Summarize. Riemann sums approximate area using rectangles. The choice sample points affects accuracy, and more intervals leads to better results. Thank you for watching.